Take it away, Paul.
All right. Welcome to the Dallas Personal Robotics Group Robot Builders Night Virtual for March 12th. This call is being recorded. If you don't want to be recorded, turn your camera off. And let's see, do we have any updates? Carl, were there updates on the slide that you needed me to talk about? Nope. Okay. The only update that I wanted to just remind people of is the DPRG in-person plus virtual monthly meeting on March 23rd. So that's the fourth Saturday of this month at 10 a.m. at the Dallas Makerspace. Enter through the northeast entrance. We will have a guest speaker. The speaker will be Rob Solzum from Kabam Robotics. Kabam Robotics is a Singapore-based robotic security company, and so Rob will be talking about their security robots, and I'm going to just quickly share a quick couple of videos about them as a teaser, I guess, for the in-person meeting, and we'll have here we go. Chrome tab, window, Chrome tab. There we go. And so hopefully you're seeing the Meet Collab video here.
Yep.
Mm-hmm. So Kabam has two robots, indoor and an outdoor security robot. So this is some imagery of the indoor robot, and Rob is the VP in the U.S. And they're expanding their operations in the U.S. And Rob is going to offer us the opportunity to tour their experience center, at which they will actually have a physical collab, and Halo is their outdoor security robot, and so we'll be able to look at them, but he'll be explaining them on Saturday the 23rd. So I encourage you to either join us in person or remotely.
So you will be streaming that for us who need to do it remote?
We will be streaming the meeting. I think we need to talk to Rob to see if we can stream the visit to the Experience Center
Sure.
separately, which will be a separate event from the talk at the meeting.
What day is that again?
So that's Saturday the 23rd is the meeting. We haven't picked a date for the visit. We'll talk about dates for the Experience Center visit at the meeting. Both of these robots are hosted by a back end that you saw the word smart popping up quite frequently, and that's the name of their back end that monitors the robots and where they are and alerts, and they got a whole cloud infrastructure. So I think it'd be a really interesting talk. Clearly they address some of the things that we try to address in our robots, things like rough terrain and navigation outdoors and indoors. I don't know any more about them than these videos, but I think it'd be really interesting to learn about them.
Is that a barrel poking out the front there? No.
Maybe all too soon, unfortunately.
Yeah.
Does kind of look like a Doctor Who robot. One of those Daleks or
Oh,
at some
yeah, that's
point-
right.
At some point, don't they all, right?
If it is a barrel sticking out the front and somebody would get injured from the barrel, is that an industrial accident?
Waiting to happen.
No operator in control, right? It's autonomous.
Yep.
Makes it a piece of equipment.
Unless it's a Dalek, in which case it has the remnants of a organic brain inside.
All right. So that's the next monthly meeting. Should be fun.
Cool.
Okay, so how about we do a roundup of who's got something to present? I've got something I can show.
I mean, I got something I can talk about.
Yeah.
No show and tell.
All right.
I got an eclipse question for Doug D, but it's not robot related, so.
That's all topics are considered. Or as they say on NPR, all things considered.
All things.
Anyone else? Otherwise, well, since I just went, how about we lead off with you, Mike? Are you ready to roll?
Sure. Yes. Yeah. So my little robot has those odometer pod wheels, and I spent quite a few days trying to get them working, and of course they work, but they seem to end up giving me worse results than my regular wheels. They weren't, somehow it wasn't good traction. I mean, especially with the one that does angle. So I said, okay, I'm gonna cut my losses and just go back to the wheels and encoders, which are very good. And maybe I'll come back some other day and try to figure it out. And then I started using the that time of flight array sensor and implemented an obstacle detection. So now it basically goes around obstacles. But I found there's a blind spot. That's when it has a can, when it's grabbing a can, it has a blind spot right in front of it. So
Go figure.
I need another sensor to take care of that. So basically, if there's something right in front, I'll just smack it. So, and that's usually, well, chances are that's where it is, but it works pretty good. And right now I'm working on doing a mapping with those sensors. And so I took them all and calculated the XY coordinates of each place that the sensor saw on the walls on the side. And then right now I'm learning how to translate it to map the real, to align to the world map instead of where the robot's pointing. And I'm getting pretty good results. So I can take the wall relative to the robot. So if it's twisted, it'll have a sort of a strange, they won't be in a line in terms of X values and Y values. It'll be having, like if you fit a line to that, or polynomial fit to it. It would have a big slope to it. And then you can take you know where the robot is roughly, because that's just what it does, with its angle relative to the starting map position, origin, and the offset. And so I'm able to twist everything and offset it, and then it lines up to where the wall is. Now, it's not exactly lining up right now, but I just had to stop for the meeting.
Really? So that's sort of like SLAM, the basic SLAM idea, isn't it? To recognize where it is based on what it's seeing.
Yeah. Well, there's data points that shows where stuff is, but comparing it to where the wall should be versus where it is, that's more coding to do a SLAM. And then the way that ROS works is they have different transformations. There's the map, which is the real origin, and then there's something called the ODOM, which is odometry, and then there's a link from that to the robot, the base link, and then ODOM, like if there's no odometry slippage, ODOM and map are exactly aligned. But the SLAM protocol able to look at the wall and see your data points, and if they're not exactly lined up, it'll adjust the ODOM weight or
The map offset.
coordinate relative to the map, and that'll fix the robot position. So I got all the data. I just have to figure out how to use it. I'd love to make a point cloud to be able to show it in RViz. So I'm trying to crack open that and trying to figure out what the format is.
Wow.
And then it's like, okay, well, if I do that, I got the data and I got that. Do I use SLAM or do I use since it's a real simple map, a square, which is what our ring is, I can probably just do it myself. So it's not a complicated geometry or anything. So I'm working on it.
Cool. That sounds
Mike,
difficult.
Yeah.
Mike, the wheels, the extra odometry wheels, what do they call those? I don't remember.
Pods.
What? I'm sorry.
Odometry pods is what
Okay.
we'll go build it on. But they're dead wheels is another name. Yeah.
Okay, and when you say they were not up to your normal encoders, is that because the encoder counts are not as high? Is it because they just didn't give you as good a results, or what?
The encoder count per meter of translation of movement is more than 3 times higher than the wheel encoders.
Okay.
It's like so it wasn't the encoder. I was able to test things out, but when it was actually moving around and sliding around, it just they weren't tracking, and I have a different geometry than what the other robots have, so I'm having to do my own math. Maybe my math fell apart.
Oh, okay. But were they way off, or?
Oh yeah, way off. Yeah, I did some simple tests, and it was still off. It wasn't consistent. Like the wheel encoders, assuming they're not slipping, was consistent. So I'm assuming that their traction on the ground isn't as good as I want it to be. So it might be my flooring and the wheel, because they are, what are those wheels that are omnidirectional wheels?
Yeah, omni wheels. Yeah. They don't have much traction for sure.
And they're sort of, so I'm thinking maybe I need to tighten it up, the force on it. There's a spring on it I can tighten up, but if I put too much down force on the odometry pods, it lifts the wheels off the ground, which causes more slipping. So, I mean,
I was just saying, watching the performance you showed us last week with the closet and the 3 cans, you know, I would just take them off and move along, you know?
Yeah. So they're doing okay for casters. I think casters might work better, but
Yeah, okay.
they're doing okay. Very
Okay.
expensive casters.
Yeah, okay, I got you. So they are performing a function.
Right. Yeah. But yeah, yeah, everything works pretty fine, except I just couldn't get those to work, and I'm thinking that they're somehow just not slipping. They're slipping on my polished floor or something. Yeah, it's like, yeah. Yeah, my floor is really shiny.
Well, that would be one of those things that would really be cool to use your ROS 2 stuff. That would, you know, where you could use them, you know, do a bag and compare their performance to the normal wheels, and you could see where the error is getting introduced. Like, is it when you're going straight? No, which means everywhere. Or is it like only when you turn, or, you know, what's going on? Be interesting.
Yeah. Well, straight was pretty good, but I can go 5 meters and get as good of a result as my wheel encoders.
Yeah.
But when I start moving around, it sort of it loses the angle. Yeah.
Okay.
And you're right, I could do that, but I just spent too many hours and days on it, and I just said, okay, I'm going back to wheel encoders for now.
Mm-hmm.
And they seem to be doing a pretty good job.
Okay. Yeah.
When you say it loses the angle, how many odometry pods do you have? Just the one?
Oh, I have 2.
Okay.
One for forward direction,
Yeah,
and one for rotation. Because that's all my kinetics do is go forward and rotate. So I just need those 2. Now, if I had a omnidirectional robot, then I'd need a 3rd one, because it has another motion. It can go sideways and.
Oh, I see. So the rotational one is mounted on the periphery, so that when the robot rotates, the odometry goes around.
Right. So you just measure the number of millimeters that wheel moves, and you know the circumference of that circle, and so you know how much it rotated, and that had a pretty good number. It seemed good. I was able to measure that and test it out. So I can go forward and in a circle, but when I do both at the same time, something bad happens.
Interesting.
Yeah. And then there's seams in my floor. It makes a little bumping sound when it goes over. And yeah.
Interesting. Okay. Well, I can go next, I guess. I have a show and tell. Let's see, if you pin me, I'm very excited that I got, let me just search. Reach. So I got Pi Dog built over the last week, and
So we're gonna have a Pi Dog competition.
well, we'll at least have some Pi Dog demos.
Yeah.
So his wake up routine. and
do the howl.
Well, I don't have the audio working, Doug, so I've got a couple of questions that I'm hoping you can help me with
Okay.
on that.
Are you using a 3 or a 4? Well, I guess that's the first
4.
question. Okay, I was using a 3, so I was using the 32-bit legacy code. Are you using the legacy code, or are you using the?
Yeah, I'm using the 64-bit legacy code. So let's see. A few of the things he does are set and
Responded to your command. Wow.
only because I'm typing in another window.
Oh, okay.
It does have can do voice commands. Did you know that, Paul?
Yes.
Okay.
This is lie down with hands out.
Yeah.
Let's see. The stretch is kind of fun, and then you can do push-ups. This is as far as I've got with this thing, Doug.
Mm-hmm.
Can I drag it out across the carpet, or?
No, it doesn't do that one.
No?
No.
I would think that'd be a classic.
Yeah, I know it would be. Let me see if have you tried to do the AI ones?
No,
Okay.
I only got it put together like the night before last, and so I powered it up for the first time yesterday.
Okay.
And,
Well, how about your ultrasonic? Is it running?
I don't know. I haven't got any.
See, that's my problem right now. If you have the ultrasonic is what it uses for crude obstacle avoidance. Okay.
Mm-hmm.
And I had it working, and it just kind of like stopped, and I was concerned that I can put the oscilloscope on it, and I realized that I'm not getting a return pulse from the but I replaced it. I replaced the sensor with another sensor and got the same result. So I don't know. I suspect it may be something to do with the code base, but the problem is I had it working at one time. Yeah, it loved the rabbit's tail. Yeah. So
Got a waggy tail.
yeah.
Well, your dog's much more dog-like than my dog.
We'll actually do a decent job of walking across the plastic. It's not so happy on carpet, but it will walk across carpet.
Is that because the servos aren't powerful enough, or does it get stuck, or what?
I don't know if
It's the classic foot problem.
Oh, okay, it just drags the foot.
No, the foot the foot really probably could use a little strip of rubber on it. Do you see it?
What's the problem, Doug?
Well, the problem is the feet aren't sticky enough.
No traction.
Yeah, there's no, or at least that's my opinion. I just say that if you wanted a little more, see, it's doing pretty good. Now, hey, can you get in front of it? Is it in patrol mode?
No, I'm just using the basic exerciser. That's as much as I've gotten,
Okay.
as far as I've got. I've only had today and last night a bit to play with it.
Okay, there's an example program called Patrol, I believe. In one of the example, there's test programs and there's example programs. So I want to say that. So what's supposed to happen in Patrol is that if he goes forward, if he detects something in a certain distance, I can't remember, 2 feet or something like that, it's supposed to stop and bark. It stops going forward and barks. So that would be a test of whether or not your ultrasonic is working.
Right.
The other way you can test it is you can go into the I think it's the PyDog directory, and I think there's a directory called test. And then you can, from the test, you can find like the ultrasonic, you can find a whole bunch of tests.
Oh, okay.
So, like I said, they did an amazingly good stuff.
Okay. Oops, it fell over. Anyway, you cut pretty good on the plastic.
Yeah, really was. He was booking it there.
Yeah, he was. So anyway, he's a pretty fun little dog. There's the IMU here, and the AI camera. I'm not sure what it is. Doug, you probably know what kind of
That's
camera.
just a standard Pi camera.
Okay.
I think it's a version 1.2 or something like that.
Okay. And then there's the board underneath the Pi is a sound direction board. It's got 3 microphones that can triangulate sound direction.
Yeah, I know. That's actually underneath on the bottom side of the board that's on top of the Pi, I believe, isn't it?
No, this is the sound. This bottom one here, sitting right on top of the chassis, is the sound direction board.
Yeah, it's also got two touch switches on the head.
Yeah, right. So
and
supposedly it'll do something if you stroke it.
Yeah, but I'm just saying it's nicely thought out kit.
It really is, and it's even quite good artistically. You know, like it's got this sort of like muscly shoulder muscle and a kind of like a neck collar thing that will light up, and it's really I think it's pretty nice from both. I want to say the documentation was great.
Yeah.
The only problems I had were where I didn't follow the instructions correctly. Other than this audio thing, so.
And they even warn you. They warn you that the audio, you might have to run it a couple of times, and that literally is true.
I ran it 3 or 4, 5 times.
I've got the audio to work. That wasn't my problem. My problem was, and I also got the AI, though it's very dumb. You know, I think you can show. It's not trained on a big model, whatever it is.
Okay.
But the potential is there.
Got one other weird thing, Doug. I don't know if yours does this, but if I power it off and then power it back on with the power switch here, it won't power back on until I plug the power cable in. Does yours do that?
I never tried it, since usually when I have it on my desk, I've already got the power cable in. But
I'd like to know if yours does that. I'm just going to switch it off here and demo that.
I don't know if there's any smart. Otherwise, it turns off your Pi kind of abruptly. You know what I mean?
Yeah.
So
and usually I do a shutdown, but because I'm live here, I'm not doing that. But okay, so I just powered it off. Now power it back on again. Oh, it woke up.
Yeah.
Well, it doesn't normally do that.
Yeah.
Well, okay, that's interesting, because in the past I've always powered it off using pseudo power off. I wonder if that does something different.
Pseudo power off or pseudo shutdown?
I use pseudo power off.
Okay.
Don't you love how the same software behaves differently on different trials?
Yeah.
Well, hold on, let me just test this.
Not just my software, then.
It's a remarkable feat.
Okay, I'm going to just bring it back up.
Yeah, see if it'll wake up.
Yeah, it's waking up. Why is my camera all blurry?
Not focusing. Huh?
Come on, camera. There we go.
There it goes.
There you go.
Okay, so my normal procedure is to make him stand up, and then I'll quit out of that, and he'll lie back down, and then I do pseudo power off. Yeah, just put this down for a sec.
I do like the way they handled the battery, though.
Yeah,
That's pretty neat. What they do is they have two, what do they call them? 18650s, and or three of them. I can't remember. I think it's only two, and they just have them attached underneath the body, I believe.
right. Well, Doug, it's not. I can't make it do it again.
Yeah, Paul, we know. We've all heard that one before.
Normally, you can't make it do something. Here, you can't make it not do something.
Anyway, that's my show and tell.
So, Paul,
Yep.
usually the reviews I've seen of like small walking robots with those micro servos is the servos are underpowered and break and stuff. Have you seen any issues with that?
So they ship servos with all metal gears. So
Okay, that's good.
as far as underpowered, I tried to make it trot on carpet, and it like jiggled around for a bit and then fell over sideways, and its legs were still waggling away. So I wouldn't say it's underpowered. It doesn't stall. It's more that it trips itself up and tips itself over.
Yeah.
Wow,
Yeah.
sounds impressive.
Yeah. Getting they did a really good job. You know, you got how many 12 servos in it?
Yeah.
And one of them's the tail, so that's not as big a deal. But
Yeah.
they essentially, you set all 12 of them to neutral, and then you move them into a sort of sit down position like this, and they have a little program that allows you to adjust them to make incremental change in each of the different
Right.
different
Which
ones.
I found was necessary because the splines on the servo head don't let you set the arms exactly at right angles.
Right.
So it's like Doug says, it's a kind of a fine tuning mechanism, and they must store away some parameters in a file somewhere.
Right. And I was saying, I considering how bad that could be, they do an excellent job in letting you set up all of those things.
Yeah, I think it's pretty cool. Pretty cool robot.
Yeah.
So anyway,
the control software is strictly their app. You don't have access to the programming.
Well, no, what they do is they provide you, I believe it's in Python, isn't it?
Yes, it's in Python.
So what you have is essentially a library of moves. Okay, so like go forward, you have a subroutine that's go forward. If you want to turn left, there's a subroutine turn left. And there's a subroutine to turn right. There's one for it to sit down. There's one for it to lay down. There's one to lay down with its legs extended. One to stick its butt in the air. One to stick its head in the air and howl. I mean, about anything you would want to do, they have a subroutine for.
Right, but how do you call these subroutines? Do you type into their app, or can you have a program that makes decisions?
Well, it's Python. You write your program if you want it.
So it's strictly Python from the command line.
Yeah, I'm just saying is, in theory, I'm sure you could look, if you wanted to, you could look at one of the subroutines and you could figure out, I mean, they're obviously passing the position of 12 servos.
Yeah, I wouldn't be all that interested in that. I would be
Yeah,
just,
that's what I'm
I want my
saying.
robot to do what I want it to do.
Right, and that's what I'm saying. So what I'm saying is, you probably, if you think about it, if you wanted the robot to get up, if you wanted a robot to go forward, if you wanted the robot to sit down, if you wanted to go left or right, I mean, they have so many things that you don't really you just have to string them along.
Right. That's what I was getting at. If I want to say, go from this room to that room and it's using its ultrasonics to detect barriers,
Yeah.
and it just makes some decisions and turns and goes.
Right. And you can swing the head too, if you wanted to.
Right.
So,
That's better than my dog.
like I say, the one that they have, we're going forward, like I say, there's one called patrolling, which on purpose, the example program, it just goes forward. And then when it runs into sees an obstacle in an event ahead, it just, it stops and barks.
Can you all see that?
You could change that program to say, when you find something, turn left.
Yeah, you could. Yeah. And it's got a 6-degree IMU. So the big problem you probably can't do is give it an absolute location. You can't tell it, well, okay, I'm at 0, 0, and I want you to go 5 feet forward. Well, you could estimate it like, well, that's going to be 15 steps or something like that. But there's no encoders or anything like that that's going to tell you that. So either you're going to have to do something slick like what Mike suggested I think he was suggesting where you could, he was using a blob detection to tell how far the blob was away by, I think we're looking at for where it was inside the height.
Right.
Otherwise, the closer you get something, the higher it goes.
Right.
And so,
Yeah.
If
So
you
here's
know
what
it's just tall, then if it looks like it's 3, then you're halfway there type thing.
yeah, I mean, you'd have to do something slick.
Right.
Okay, because you're not going to get it's not going to have something that's going to tell you, well, you went exactly 6 inches. There's one that'll tell you that you just turned 20 degrees, but being quite honest, I'm not sure if you gave it a degree, said, okay, I want to turn 90 degrees, and you use the turn left command, I'm not sure, it's not going to do a turn in place, I don't believe. It's just going to veer to the left, so it's going to be a very gradual turn.
Mm-hmm.
Okay, but so there is rooms for things you could do, and
So
they do.
here's what the code looks like. You instantiate a PyDog as my dog, and then you call my dog with various methods like set the RGB strip mode or do an action, and then you give it the name of the action, and you can set the speed for how quickly it's supposed to do that action.
So you can change the color of the strip in the front?
Yeah.
Oh yeah.
It's RGB.
Okay. Yeah, its original purpose is to provide emotions to the dog. So like if it's hot, if it's mad, it's red. If it's calm, it's blue. But
yes.
I never saw any. That doesn't interest me anymore. But it does. There are some of the other examples that use it to flash and do all sorts of cool things.
Do the Cylon thing where you piss it off and it turns red and starts going back and forth.
That's a cool one. That'd be a good, neat one, Ray. And I haven't. What do they call that? There's a name for that. A Larson scanner. It's a Larson scanner.
Oh, okay.
And so the actions, when you ask it to do an interesting aspect of the programming model is when you ask it to do an action, I believe it starts it immediately, and then you have to wait until the action is done.
Yeah, and if you look, slide to the bottom. They always put it in. In sitting mode in the end, and they have it in such a way that.
My dot close puts it in, makes it sit, so it puts it back into a safe state.
Yeah, so that's kind of cool.
Yeah. So anyway,
Tomorrow from Amazon.
what's that?
You can get it tomorrow if you order from Amazon.
Yeah,
That's right. That's right. And that was about how it worked for me. It was like, okay, I ordered from Amazon, came about 2 days later, and then I started assembling it, and probably took about 5 or 6 evenings to assemble. Well, it just arrived last Tuesday, and I waved the box around, and then I started assembling it Wednesday, and I was done by Sunday, and Monday, and that was just like working evenings, sometimes during the day. And so I'm going to guess probably 10 hours to assemble it, maybe. It's just a swag. But anyway, Doug, sounds like you didn't have problems with audio. You got it to work.
yeah, I got no plans with Paul, and I do have some problems, I believe. Let's see, what is it? Since I'm using the 32-bit one of the libraries won't allow you to do something. And I have had it like, it'll do the AI, but there's something that it calls a function that's only in the 64-bit version.
And are you using it with a Pi 3?
Well, that's what I'm doing. I'm
Okay.
curious of, it might be time for me to break out a Pi 4. I'm curious, how are you keeping it cool? Or is it just, are you using any cooling at all?
No.
Okay. Pi 4, maybe at that level this guy's using it. I don't think it's using it very hard.
Yeah, until you start using AI or something. But yeah.
Yeah. So
Perhaps some heat sinks on it.
the only reason why I'd want to do it is because I can't use apparently the 3 doesn't use the 64-bit. You can't.
Right.
You can't put it on there.
Right. It doesn't have 64-bit capability.
Yeah.
So I thought I'd try putting ROS on it just so I can capture a bag with the IMU data and see how much it wobbles and see what its velocity profile looks like. I just thought that'd be interesting to graph.
Yeah, it'd also be interesting to, it would take some work, but it'd be figuring out, okay, if it's on its side, is there any way to position the legs to make it tilt so that it would reestablish itself?
That's an interesting idea.
I mean, I'm not sure how you do it without twisting, not a waist twist or anything, but it would be interesting to see if it could be done.
Or you could put an add-on where it has something that stick out the side and helps it to start to sit up.
Yeah, you might be able to make the tail more substantial, if you know what I mean. Yeah.
Interesting idea.
So anyway, it's kind of cool.
All right. Well, that's what I had. Carl, you were next on the list.
Okay.
You're muted, Carl.
Where's Paul's star?
Paul does need a star. We need to.
He's got it. He's got it.
Okay. I'll wait the star for myself.
All right.
Nice. Thank you, Jim, for the reminder. So I had a non-robot-y question, if we want to do that, and this is for Doug, astronomer man, starman. Eclipses are coming up to us here close very soon in Dallas, and I'm wondering. I went and bought a handful of the little filmy, cheapy eye safety glasses, but I also got a 70 millimeter, same kind of paper film thing for 70 millimeter camera lens. And I'm wondering, have you done any homework on exposure, how to deal with your cameras safely?
So I have done some experimenting with that. The last eclipse, which was not total, but annular, I took my Nikon with my 300 prime lens, several $1,000s worth of lens. I trusted to one of those filming things, and it worked out just great. And you have to play with the settings, and you don't have to wait for an eclipse to play with those settings. The sun's the same every day, even on the eclipse day. So you can just go outside with your filter over your lens and take pictures and see what you get. I've seen several YouTube videos lately where everybody is saying, this ISO, this shutter speed, that kind of stuff. But I haven't paid a lot of attention, and I don't remember exactly what I used last time. I just took pictures till I liked it.
All right. So, because I've seen there's some kind of YouTube or something, because I have the 70 millimeter I only have an old D80, Nikon D80, but with decent lens. And then we have the iPhone 14 Pro, right?
Right.
And somewhere I saw someone saying that you don't need to worry about the filter for these.
Always worry about the filter for every lens.
Really?
That's what I was told.
Huh. Because when you're outside, and taking photos of people in
Just
the
like with your D80, when you're outside taking photos, it takes photos. And the D80 can actually take a brief photo of the sun, but you don't want to be doing any repetitive or long time things. Your eyes can look at the sun, but you look at it briefly and you look away. Camera lenses are the same.
Yeah, okay.
Yeah, for any length of time, it'll burn the just like your eyeball.
Right.
It'll burn the sensor just as bad as the eyeball. So
Right.
So you would lean towards one of the protective films, regardless of whatever. Just
what I saw people doing was taking those glasses and shooting through those with that camera on the.
Yeah, I imagined that as well, because these lenses are small enough.
Oh yeah.
But you get the good 70 millimeter, 210 focal length, 35 millimeter lens, and the glasses isn't going to cover it.
Right. You've got to have a sheet of film for that, and they sell it in sheets.
Yeah.
Fort Worth Camera, I think, is going to be having a class on this. As long as we're talking, I have a note here. Get the date right instead of giving out bum information.
So apologies for those.
They're selling sheets of that stuff. Fort Worth Camera is on Camp Bowie on the south side of 20.
All right. Yeah, I found a place online that sells sheets or the whatever.
It's going to come here. I get all this email, tons and tons of crap.
This might be too small for your lens, Carl, but this is like $8 on Amazon or something.
Yeah, that looks like it's about the right size.
Yeah, so it's supposedly it calls itself a smartphone solar imaging photo lens.
All right.
There we go. Whoop. Fort Worth Camera. They are having training classes on March 15th and 30th, and they're selling lots of stuff and teaching you how to use it.
Huh.
That's the one on Camp Bowie, south of 20. And they're very happy and knowledgeable people. I don't want to piss anybody off on the internet, and it may be watched later by somebody else, but I live in Arlington. I drive past more than one camera store to get to Fort Worth Camera because they're better.
Yeah.
Just FYI.
All right. Well, thank you for that.
All right. Anyone else got anything, or shall we switch to open mic?
Oh, well,
I can share
going
something.
on with other people, I've got something brief.
Yeah.
We were talking about robot dogs. Robo-dog, let me unpin you. Robo-dog, who's behind me here, dead in the water again. I blew its serial connector on the Arduino somehow. And I went to Micro Center and I got 2 more Arduinos so that I could replace it. I got the Raspberry 4 and the Raspberry 5 just for impulses. And I got this fan for cooling the Raspberry 5, and that whole price of that stuff was about $200. Your RoboDog is $179, and it actually does a lot more than this stuff I got in my hands here. And it looks like a lot better than that thing behind me, which I've worked on, and it's kind of cool. It's version 1, and I've learned some things, but I don't know if I'm going to repair it. I got the Mega so that I could replace it and keep going. But I'm wondering, after seeing your new toy, if I can get that tomorrow and I get it done by April 6th to put it on my back. That's not nearly as heavy as RoboDog over here. That's 20 pounds. And I've tried it, and it's wearable, but I wouldn't want to wear it all day. So that's my story.
But yours is bigger. Bigger is always cooler.
But yours is steampunk. The other one's.
Well, maybe I can steampunk up that other one. It's just a starter thing. You can put something over it.
And Doug, yours is scratch built. Let's be clear. Yours is scratch built, so there's some energy and love in that one.
Yeah. So
That's version 1 love.
That's right.
One should not minimize the
I will probably replace the Arduino just because I've got so much other stuff in there. It's just I was so frustrated the other day when that little, I don't know if you can see it because it's probably too small, but there's a RxTX lights right here that shows the serial communications. They don't work anymore on RoboDog. It quit right in the middle of command. So somehow I burned something out there. So I can just unplug that one and plug this one in, and it probably will start working immediately again. And I'm sure I will try that in a day or so. It took me a while to get over being frustrated. Every time it dies, I keep saying, well, that's the last one. Let me go dig a hole. But then I keep saying, I can't give up. That's not the kind of guy I am. So,
Hey, Doug,
yeah.
is everything else on it working?
The rest of the dog works. It lights up
No.
like the controllers work, but the thing does nothing because it depends on the serial commands from the Pi to the Arduino to do everything.
Well, I'll be quite honest. On those Arduino boards, they're pretty damn tough. And
Also, too, it's the first time I've had trouble, but I verified it when I plugged the computer into the Arduino board to upload the program. It starts to upload and it never finishes. Those RxTX lights never flash. On the new one I just bought, they do flash.
one thing, how are you powering it up?
I have a 9-volt on the Arduino. They have this 9-volt plug-in, and I have a 9 volts going to it from my.
Okay, here's I have on the when I've ever had an Arduino issue, whether it be Mega or Uno, it's always been the LM1115 that's on there.
Or 1.7.
Was it 1.7? No, it's 1.5, isn't it?
What's that?
Anyway, it's the power supply chip. So
Yeah, the linear regulator.
yeah, the linear regulator goes bad. So what you should do is push in your 9 volts, okay? Get your voltmeter and go from ground to the 3 pins on it. And you should be able to find the 5-volt output. If you don't find the 5-volt output, if it's not there, then that's what's wrong. And you can buy those, and get replacement those. What I'm trying to do is keep you from having to throw the board away.
Yeah. Well, I may donate to somebody else. That sounds like unsoldering and soldering.
Yeah, but it's not hard.
Yeah, the board only costs $50.
$50?
$50 may seem a lot more to some people than it did to me. I bought 2 of them just in case I blew one out.
$50?
They're not 50 each, are they?
well, that's the Mega. Yeah, those are pricey.
Yeah.
Wow. Oh, but that's the an official
That was a
Arduino one, right?
The full-on branded ones.
Yeah.
How much was your Pi 5?
Yeah, I did get the Pi 5, and that was $79.99.
Yeah, that's MSRP. That's what I paid for mine. Yeah.
Right.
Yeah.
The Pi 4, $74.99. These were both 8 gigabytes, so they were more expensive than the cheaper version.
I would have got just 2 5s.
Hey, so Doug, you
I
mentioned.
hear the 5 has some differences, then I wanted the 4 will do what I want it to do right out of the box.
Yeah.
The 5, I have to figure out what the changes are.
Well, run it through Docker. That's what we did for the workshop. Yeah.
Yeah.
But if you don't know Docker, that's another stair to climb.
I haven't played with Docker yet. I've thought about it, but never actually done it. So like ROS, I keep thinking about it, but not doing it.
Yeah, well, 5 doesn't support ROS straight out of the box, so yeah,
Does not?
Docker does not.
Yeah, see, they don't quite have it ready for prime time. So I bought one just to play with, but I don't think I'm going to use it in anything right now.
Yeah.
I figured as long as it's out there and as long as they had them, I'd get one.
I've had pretty good luck with the inland clones. And they're like 20 bucks for a mega.
Where?
At Micro Center.
I got this mega at Micro Center for $48.99.
Yeah, but that's an official Arduino, I think.
Yeah, one of the other ones.
Yeah. I don't know if other people have, have you guys had pretty good experience with inland clones or?
I haven't heard anywhere anybody having real problems with them.
Yeah.
Every once in a while you find somebody complaining that it doesn't handle a library well.
Yeah, I've had pretty good luck with them. And
So
I
Doug, you
think I found
mentioned
the
the
ultimate test. They don't do well with lightning strikes.
Is it hooked up to the dog with the TXRX, or could that be the problem?
I have not tried unplugging the power to the Arduino. And I'll probably do that in just a minute when I'm not taking everybody's time. But I have plugged the computer into it and uploaded the program, and it refuses to upload because it doesn't do the RxTX. The serial board, when I was running the program, and I have talking between the Pi and the Arduino, and it echoes on my screen what it's getting, and it said no serial, no serial, no serial. And since then, the RxTX lights will not light up when I'm trying to upload, which they do on the other board. I'm going to try that in just a moment without the power plugged in case, when you plug your computer in, it has enough power on the serial connection to do its job for uploading.
Yeah, so
you power up.
I was just suggesting you test it without the serial plugs connected to anything in case those are the problem, if one of those wires shorted or something.
Right, and I can upload a test motor program that doesn't depend on the Pi to send it stuff. And I might try that too.
Yeah.
But once again, I'm just trying to narrow down why this board isn't exactly what I want it to be, and can I use it for something or throw it away.
Yeah.
Right now, I can't get anything new on it because it refuses to upload programs. I have enough trouble with hardware without having to figure out why one's partially working.
There's one other thing too to consider. If you have on your program, if you're using that port with a serial program,
Yes.
and I'm not talking about the one that's in Arduino because it'll shut the port off when it uploads. But if you're using something like
The SPI port?
I don't know. There's different names for different ports. I think the one I used is it's called RealTerm. If you have RealTerm running on that port, then when you try to use the port on the Arduino, it'll say it fails to upload because the port's already open.
Yeah. Right now, the only serial I'm doing is in the USB plug-in port. I'm not using any of the other serial options.
Okay.
Normally, real convenient for the Pi to talk to the Arduino over that serial cable. No, it just blew something there, and you're probably right about it blowing that one, whatever that's called, the regulator, the electricity.
Yeah, regulator.
Yeah, regulator. And truth to tell, full disclosure, I had not had a couple of wires plugged in, and I plugged them in just before this happened. But they should not have been a problem because I plugged them in to what they were supposed to be in. They had been knocked out before. There was a 5 volts to the motor controllers and a ground to the motor controllers. Neither one of those should have caused me any trouble. Matter of fact, when I plugged them in, the motor started working again. They hadn't been working. So I fixed one problem and broke something else. I finally got all the hardware on the darn thing so I could hook it up to my backpack, and bustling all that hardware around it undone some of my wires. And when I redid them, something else went wrong. But on the plus side, the thing Paul had actually does dog-like behaviors, which I'd intended for this guy to do, but it's too heavy for the motors and it doesn't do anything. I had to hard lock these legs into place because I couldn't do any sit down and stand up and everything. The motors just weren't strong enough. Now, I didn't gear them differently. I didn't try to do any special, like I thought about spooling some wire over a spool, and that might be better than my rubber pulley. I had a rubber pulley with teeth, and it just stripped the teeth out because it wasn't strong enough to actually do it. But if I'd done the pulling of the wire from one thing to the other, it might have done it. But, I gave up on that because I was trying to get the darn thing at least rolling. And it finally got the rolling. I was so excited. I got the harness stuff on it, and I was really terribly excited. And then it did something bad. It died again. So I'm not totally giving up on it. It may be ready in April, or I may order this other one and see what I can do before April.
So a thought about the motors not being strong enough. One of the tricks I saw quite often on the FTC robots was using rubber bands or springs to help fight against gravity so that the motors didn't have to fight all of gravity by themselves.
Right, that's a good idea. And I thought spooling some thread or string around a spool would have better grip than that rubber pulley did. The teeth in that pulley, I couldn't tension that tight enough to make it do its job. Even though the motor was supposed to be able to handle that much weight, the pulley couldn't handle that much weight. So I'm pretty much done. We can open mic it, and I'm going to turn around and start seeing if I can test a few things here. You might see me in the background.
Okay.
All right. Thanks, Doug.
I got something to show.
Yeah.
Okay. If you can pin me, that would be good.
Oh, I just realized you guys are a different time zone now. Arizona doesn't change. That's why you guys are half underway.
Oh.
I was wondering why it sounded like I missed something. Okay, I got it. Have to adjust my time.
Okay. Anyway, I'm still kind of playing around with three-phase motors. This is actually one of them right here. It did or still does have, here's another one. It does have an encoder in the back that's back here. And it just has I guess a cog on the front for, I can stop moving here, for a belt, but it's just pressed on, you can pull it off. Anyway, so I have the same thing here. This little flicker that you see, the blue, kind of wobbling back and forth, the motor is slowly spinning. And that's, I wanted to experiment. You can also use encoders like the ones on the backs of these motors as part of the control for simple FOC. So this is just a little power supply board here. It's putting out 3 volts. The blue flashing light over here is an ESP32. The red light is the DRV. I think it's the 8313. That's basically the motor driver board. So I hooked it up and was looking, trying to use encoder counts, but the encoder counts out of these small encoders is around 200 pulses per revolution. And I don't think it's enough. It seemed like other people had issues with that, looking online. So I took one of the AS5600s, if I can hold it still enough, and put it on the front of this motor here. So this printed circuit board is the AS5600 or the magnetic rotary sensor that you can get from Seed and a couple other AMS, I think, was the company that made it originally. Anyway, so right now it's set to rotate at 10 radians per second. So that little flashing blue it's pretty faint. You can just barely see it there. It's just a piece of tape that's on that cog and it's spinning around. So it works fairly well. Any of them with the AS5600. There might be an issue with these encoders because this one, I want to say this one had a count of 256, and this one I know I took apart, and that's an old L-com motor, and it's got a 200 count encoder on the back, and the AS56 right now is I can't remember if I think it's 8,192 counts per revolution. It's a lot of counts. It's either that or 4,000. I forget which. 4,096 maybe. One of the two. Anyway, a lot more counts than what's available from these encoders, and it seems to work, pretty good, even though the number of pole pairs in these motors is a lot less than in those the little gimbal motors. These have, as far as the configuration, it says it has 2 pole pairs, and the gimbal motors have 7, and you can get higher pole pair counts, 11, 16. So it just depends on what the specs of the motor are. Anyway, so it works fairly well. It's fairly smooth. I can also do positioning. I actually had to play around with PID coefficients on the different motors because it was set up for. Let's see if I can get out of this here. Okay. Here we go. Don't know if you can see it. I guess I gotta present, don't I? Share. Okay. Anyway, this is one of the programs that, I used the examples and kind of modified it to fit with what I had to work with. And as far as I can tell right now, it is a position loop around a velocity loop. And if I can't do it with this motor driver, but if you get the motor drivers that you can actually sense current, you can do a torque loop surrounded by a velocity loop surrounded by a position loop. So you can get some pretty, complex control with it. So right now this is set for velocity. Let's see. Now it doesn't give you the enumeration types, but velocity is one, angle is the other. I think torque is another one, but I can't use that with this. Anyway, so just playing around with, and this is actually just has P and I coefficients, no D. I was able to get it work much better. It was kind of overshooting, so you could say you wanted it to rotate to like 6.28 or one revolution, 6.28 radians, and it would swing to it and then kind of oscillate back and forth, and just playing around with some of the PID coefficients, got that to stabilize, and so now it pretty much, you tell it to go to a position, it swings to the position, and I would say it's more critically damped than underdamped, because it, oscillating back and forth meant it was underdamped. So, so it's pretty neat. It's fairly easy to control it. I was a little disappointed that the encoder counts were so low on these motors. I hadn't looked at them in a while, but if I can put the AS5600, say, on the back in place of the encoders, I think they'll work okay. And I still don't know what the torque is. It's in the, I can kind of grab the shaft with my fingers and try to get it to stop, and it'll actually fight me a little bit to try to keep it spinning at a certain speed. Or you can hold it, and then when you tell it to go to a certain position, it'll kind of fight you to get that motor shaft to that position. So anyway, that is all I had.
Well, you're just a motor expert.
Oh God, no! I'm just starting with 3-phase motors. It's but it is interesting. I think you can do, some interesting things, and it's kind of like anything. There's a lot of people that put in a lot of effort to improve the simple FOC libraries, and so now I get to use them without trying to figure all that out. Anyhow.
Nice. Anyone else got anything?
I've got something perhaps of interest. You guys know I have a Pi 5. One of the things it can do is actually you can attach a VME appliance to it. So what I did a month ago, I don't know if you can see this. So there's a Pi 5. Can you the background's trying. Anyway, there's a M.2 on there. So this Pi 5 is booting up off of the M.2.
So that's an SSD or something?
Yeah. So
Okay.
M.2 NM. Let me see if I can get rid of this blurry background. It's a setting. Can you see that? It's a M.2 on this. So it's a 1 terabyte. Now, so it was not intended to be a terabyte. It turns out this little controller, and I'll actually put it in the. Tell you what, I'll put it into the. So what I'm buying. It's finicky. I actually bought a Western Digital Black, and it didn't work.
Somebody needs to mute your mic because it's echoing.
But what I had actually, through another project, I had a 1 terabyte Lexar, which is, I don't know, medium ground. It's not nearly as high as a Western Digital or something like that, and it works. So now I got a terabyte on my Pi 5, and it boots up in 20 seconds. So thought I'd pass that along. It works, but you have to be careful about what M.2 you use. I'll never fill this up, a terabyte.
Yeah.
On a Pi.
Yeah. Hey, Brandon, I've been screwing around along similar veins, and I've evaluated 2 boards. Let's see if I can find it.
Yeah, this was the Geek Worm. I did put a link into the discussion area so you can see what board. It's only $15, so it's not really expensive.
Yeah.
And
The one I like the most is the one from Panaromi. It works real easy. It's about the same price. It goes underneath the Pi.
Oh, yeah.
Okay. Now I have one that goes on top of the Pi, but it's not so good because it uses the first 10 pins.
So this one here bypasses the pins. That's why I chose it. And because I have that Pi attached to the monitor, I couldn't put something on the underside.
Mm-hmm.
So this one here is minimal square footage, and the pins are accessible, and the fan on the Pi 5 is still viable.
Still good. Yeah.
Yeah.
The one that I have that goes on the top does a good job of allowing you to use one of the new Pi 5 style fans.
How is it wired? Is there a ribbon cable or something?
Yeah.
Yeah.
Right.
Okay.
There is.
Mm-hmm.
Just like the camera, but it's got the PC. It's a PCIe. That's what it is. A PCIe interface. So it has a little ribbon cable that flexes either to the top or the bottom.
Okay.
Yeah, the one I'm using is if you pin this, you can probably see it. It's called the Pimoroni MVME base. And it's pretty nice. It has one of the things, I mean, they thought it through. The one that's Brandon's got looks like it's more minimal.
It is, right.
And does it block the SD card port?
No.
Okay, so this one does that too. It has a dog-legged,
yeah,
flex cable. This just pops on the bottom, so you can have whatever cooling solution you want on the top. It's about the same price. I don't know exactly, but like I say, you got to be careful when you're buying these because they're starting to be popular. This type of board is starting to get popular, and there are definitely some that are better than others. You don't have, if it uses any of the GPIO strip, I would avoid it. You don't have to use the GPIO strip.
So it just plugs into the SD card slot?
No, it just...
No.
What does it plug into?
The ribbon comes out the PCIe port, I believe.
Yeah, it's on the end.
Oh.
So it just literally if your Pi is on this, it just literally pops right into it.
Yeah. Oh.
Now the one I got, if you have it recommends a certain voltage and current. Now, if you actually use one that has a higher current, they do have a power port that you can plug into if you need it. So you would actually supply that separately.
Yeah, I'm using these little 2230 format boards. This one I think is 128 gig, which is fine for this stuff. But you can use, like you said, all the way up to this one. The Pimoroni will go up to a 2280, which is I think what Brandon's got.
Yeah, it's full size. Yeah.
Yeah. So, and these things they're only about $10. So. $10 to $15, so the drives are cheap. And if you're buying them from Amazon, what you do is you try to fill them up, and you look at how the controller handles the cache. And if you have like good speed at the beginning and all of a sudden it slows down to a crawl, send that one back to Amazon, and I can put a link for one that I found that's been I think is a good deal. I've bought about 4 of them for different things. I've been using the Orange Pi 5, no matter which version you get, Pi 5B, 5, or 5 Plus, all have this port built in. So but I'm not Pi 5, the Orange Pi 5 looks like a great board. I'm still screwing around with it. But if you're used to the support you get with a Raspberry Pi, you're going to be disappointed because it's just not there, even though it looks like a great board. So anyway, I'll put that link in.
So putting an SSD on there, is there like, some sort of performance benchmark that, your Raspberry Pi looks like it's in turbo mode or something, or?
If you're doing a memory intensive operation, no.
Mm-hmm.
If you're doing something that would be hitting your drive, then yeah, quite a bit, and also a little more robust. Oh, and these NME, whatever they call them.
NMVE.
Yeah, those drives are very, very fast. Okay. And these little chips are made for things like the Chromebooks and stuff like that. That's where they go into, things like little tablets. They're, like I say, I think that, I only have one Pi 5, and I decided to put it in there. Like I say, the only reason this guy is not on him is because I'm evaluating another one that I got, and I wasn't as happy. It works fine. It's just that I don't like to have my GPIO port burdened.
You asked about performance. It's informal just by inspection, but the boot up is significantly faster with the SSD.
Oh, yeah.
I mean, I was surprised.
And a big one like Brandon's got, if you think about it, you won't be writing to the cell very often because there's no way you're going to be using a megabit. So the balancing software in there is, so in theory, his would last forever. You know what I mean? Or until, so anyway, yeah, I'm using SSDs on all my 4s and 5s now. Now I don't have a board like this for the 4, but I just plug it in. So they're using USB 3, but it does work better. And I think it's much more reliable than an SD card too.
Well, that's primarily why I went towards this. I was reading people who are building things and said these SD cards unexpectedly go out, and they said, so that's why I switched over. It's faster too.
Yeah, if you think about it, when where you lose your SD card is when you interrupt it while you're writing to it. You know what I'm saying? So you're trying to write something to it, and you turn the SD card, turn the whole thing off, boop, and that's when it gets screwed up.
But why is the NVMe any different?
No, it isn't, but it's 20 times faster.
So it's chance.
Your window is smaller.
Okay.
I mean, there may be other safeguards in it, Carl, that I don't know about, but that's at least on the first order, that's one of them. Your period of vulnerability is much smaller. So anyway, yeah.
I've got a couple of things to share. The first is that this Saturday, SRS, Seattle Robotics Society, is having their monthly meeting, and Bob Cook, who is one of their, he's kind of like the David Anderson of SRS, I guess. Famous for his Robo Magellan robot, and he did an excellent talk in December on AI recognition of cones, and he's doing a talk this Saturday on other aspects of his Robo Magellan robot. So it happens at noon Central Time, so I guess 10 o'clock Pacific. And so I'm going to try and make that. I thought that'd be real interesting for those of us who like Robo Columbus, Robo Magellan outdoor robots. The second thing I wanted to ask if anyone's tried the DW1000 Decawave UWB ranging sensor.
Decawave. Is that what you have, Paul? Or
no,
Luke?
No, I haven't messed with it. It's been around for a lot of years, and UWB is alleged to have an accuracy of about 10 centimeters, which would be okay for indoor applications using, trilateration for indoor or outdoor, for that matter, global positioning. But I was thinking it'd be kind of good for areas where RTK GPS won't work, like under trees, dense cover, and so forth. And so I've been looking at it, and it seems to me you can get the modules for about $20,
Really?
or get them on something like an ESP32 for more. But like SparkFun sells them on a module, and I've been seeing very differing reports on whether their range is achievable, and whether you can actually get the real range out of them or actually get the real accuracy out of them. And so I just wondered if anyone has tried one of them.
Do you have any part numbers or something we can look at?
What? Sorry, part number? Yeah. If you
Or
just
a link.
Or a web page?
Yeah. Let me share that.
Doug's going undercover.
So, I mean, there's lots of people offer the DW1000, but I haven't seen much data on how well they work. So, this BU01 is the actual UWB module that sells for about $20, and it emits a ultra wideband signal that can actually carry data as well at about 6 megabits a second. But out of the module, you get a range to everything it's talking to, and so there are like various Arduino sketches that.
So are they deriving that from like an RSSI received signal strength indicator?
No, it's time of flight.
Oh.
It's round trip time. So the time inside the chip until it replies is very accurately known to be, I think if I remember right, of the order of 600 picoseconds, but the accuracy of it is asserted to be of the 15 picosecond range, which gives you down in the centimeter kind of range. But then with RF effects, they say you can't expect more than about 10 centimeters. And so this particular article happens to, and I can paste that into the chat.
That's about 4 inches. That's not bad.
Yeah, right. Perfectly good for a lot of applications, like mowing, and when you can't get, when you're under trees and RTK doesn't work well, or maybe even for some Roborama contests, although many of them don't allow beacons, and so this would be a beacon, because the way these things work is you have beacons that they call anchors, is just their term for a beacon, and then the rover has what they call a tag, and each side can determine the distance to all of the neighbors that it's communicating with, and so the tag can communicate its distance, can measure its distance to the anchors or beacons, which in turn lets it trilaterate it and determine its position, and then the anchors can do the same thing, presumably for each other and certainly for the tag. So it's supposedly used in like warehouse inventorying or tracking objects being moved around in buildings between different floors, like maybe hospitals, warehouses, commercial buildings, and so forth. And so anyway, it's been around for a long time, and I've always been kind of interested in it, but I've only recently started to see sketches come out for for an Arduino environment, and ESP32 is built on it, and I think it'd be really interesting to try, but I just wondered if anyone knows anything more about them.
Yeah.
Well, isn't one characteristic of the ultra wideband also that it has a pretty far distance it can do with low power?
Yes. Yeah, absolutely. It sends its signal below the noise threshold by tens of dBs, is my understanding. And its instantaneous power on any particular frequency is super low, well below the noise floor. So it's sort of not considered something that has to be regulated in the way that devices transmitting on the ISS, what's it called, ISS, Industrial Scientific, whatever it is, band, 2.4 gigahertz and 5 gigahertz have to be regulated and registered, licensed, all that kind of stuff.
So any idea with these modules you're looking at, what kind of distance they can measure to? Outside inside, right? But
I'm trying to remember. I thought it was in the sort of 100 meters range. But let me see if I can find it real quick.
It looks like there's a UWB 3000. I don't know if it's 3 times better, but
like science fiction theater 3001.
So I'm seeing numbers like 30 meters outdoor line of sight.
it's not bad.
Someone said that after 90 meters they'd lose the signal.
Well, 30 meters is over 100 feet, right?
Yeah.
But it's kind of borderline for DPRG's Robo Columbus.
For the whole course, yes.
Yeah, you'd need multiple beacons.
Right. Well, you need a minimum of 3 anyway to trilaterate.
Okay.
Yeah, and technically, right now, the rules don't allow beacons, except for RTK.
Yeah. But even, just outside of DPRG contests, it seems like a interesting technology.
Mhm.
And that's all I had.
So, Paul, what does the ESP32 do?
In this application, I don't know. I was looking through my search history because I came across it during the week, and I imagine it like reads a chip and reads the range and displays it and stuff like that. But
Okay.
I haven't really looked, sets the chip up. But
I guess the question I really should have asked was, what is the minimal beacon? Can you do like I'm going to just say, a small LP, small single cell LiPo battery, one of these chips and an antenna, and is that good to go, or do you need a microprocessor and blah, blah, blah? I'm just wondering.
It's got a SPI interface, so you're going to have something that can talk to it over SPI.
So even for a beacon, you need a SPI interface.
Yeah.
Okay.
And a tag, I would think, also, because you got to I would think you got to initialize the thing.
Mm-hmm. Okay. Yeah. All right.
But like, so Ali has a BU01. Well, so Arduino has a Nano with an Arduino. Sorry. Yeah, I was really just fishing for anyone who had any experience or knowledge at all on this thing. Hey, sounds like. All right.
You're the maverick, Paul, at this point. You're out in front.
I experimented a little bit with PID auto tuning this week. If there's any interest in that, I can talk about it for a minute.
Sure.
Yeah.
I don't know if anybody's done that before. I had not. I'm going to share.
I've pushed the button on oh God, what are those things? No, I can't think of their name. Anyway.
Okay, this one. Let's see if this will.
And it's been a few weeks since we've had a good PID loop discussion, so bring it on.
Oh, why not? Right. You can see that, I assume.
Yes.
Okay. I've probably talked to this group before about learning a little bit about how to use the Ziegler-Nichols tuning method a few years ago when I first started to use speed regulators on a robot. And this is the approach I started to use. I can talk about that some more later if anybody wants me to. I had a little presentation on it from when I did my tri-robot. I applied that to the robot I'm currently working on for the 6-can contest in order to get some starting points for the coefficients for the PID loop. The two motors I've got turn out to be different. So these tables show the values that I got from applying this manual tuning method. It's one of the simpler tuning methods around. And depending upon how responsive you want the PID loop to be, you can pick various values here. And I usually go through and try them all because they're fairly easy to use. They're starting points. They're not perfect PID parameters. And when I applied them to the two motors I got results like this. It's not great. The overshoot and undershoot still needs to be manually tuned out, but it produces very, very good responses to what is a step input in speed reference. So I ask it to go to 100 RPM and it goes to exactly 100 RPM. It just overshoots a bit and then undershoots when I turn it off. So it's not bad. You can ignore the funny green lines at the bottom. That's just other things I have as I'm tuning the loops I have on this Arduino. It gives me a better timeline for what's happening. So I thought, rather than mess around manually tuning these things, because I'm never very good at that, I have occasionally run across references to auto-tuning software for tuning PID loops. I thought I would look into this a little bit and see what happens. When I researched it a bit, I quickly ran across three of them. One of them is called S-Tuner, and S-Tuner is provided as part of the Arduino library package. It looks fairly complex, so when I tried to find out more about examples of usage, the only examples I could find in all the forums I looked at were people who were using it in temperature control loops, closed loop temperature control, usually for beer making apparatus. And that's all I could find. Nobody seemed to use it for anything else except that. So, and it's pretty complicated, so I looked on a bit. Now, the Arduino library provides one PID library, which is by a guy named Brett Beauregard. I think somebody's mentioned it before. It's the one I'm using with my Arduino, with my robots. It's very good, and he's got extremely good write-ups in his blog on how he developed it and how to get maximum use out of it. He also wrote an auto tuner. He wrote it a long, long time ago. The GitHub is about 13 years old. He acknowledges that it is not very good. He does not recommend it, but he did do a short write-up in his blog on how to use it. It's very complicated to set up and use. There's probably 10 or 12 parameters you have to mess around with before you can even start to use it. Plus, the code hasn't been touched in 13 years, so it didn't give me a really good feel. So I ran across this third one, which had a few good reviews. It's relatively simple. There's only a small number of parameters to set up in it, and it was easy to add to a version of my code, so I could run it as part of the software package on my Arduino. So I ran it. When you run this thing, basically what it does with the parameters you give it is it simply gives your motor a reference, monitors some results, and turns it off, and then gives it some more references. And it does this 8 times in a row. The blue line is the reference, the speed reference, and the red line is the speed measurement, which it's looking at to get some feeling for what the response of the plant is that you're trying to control. This doesn't look bad. This looks like it's okay stuff. I ran it several times, which is why you see a couple of graphs here. So when I ran this thing a bunch of times on each of my motors, and I took a look at the data, which here we are. So I took the PID parameters for a low response solution, and this is what I got when I tested my PID loop. This is horrible. This basically says, give it a reference, and the speed just goes crazy. This thing oscillates like mad. It's a highly unstable set of starting PID parameters. So I was extremely disappointed. It kind of reinforces what I've been reading that say that auto tuners are really hard to get to work right and aren't that good anyway. So I don't know. For what it's worth, these are the PID parameters which this auto tuner gave me for a condition of basic PID, a classic PID loop, and what's called a no overshoot. I used the no overshoot values. I ran this multiple times. The PID values it produced seemed reasonable. They seemed consistent at least. So I averaged them out and used the bottom set in order to test the motors. Produced really, really awful results. So the end result here is certainly this particular tuner, which if you look in GitHub and search for Jack W01, you'll find the code and his extremely sparse write-up. I wouldn't really recommend it. that was the solution. Is I tried it, it fails. I don't recommend.
Tom, hey, can you back up to the last chart you showed?
Yeah.
I'm wondering here when I look at that chart, because the time scale and excuse me, when I see that chart and I see those kinds of dropouts in the blue, and I think you said the blue is the reference.
The blue is the reference.
Well, it makes me think that you've got a sampling rate problem, because if the blue is the reference, that should be a nice, regular, clean signal, right?
Yeah.
And if this thing, if whatever you've got is not putting out a nice, clean signal, it suggests to me that either it's not sampled properly in the way that it's creating that signal, or whatever mechanism you're using to measure the thing is not measuring it right very well.
Yeah. Now, Carl, this was my normal PID loop with the new set of 3 parameters in it. And when I say my normal PID loop, I mean the PID loop that produces this with the parameters I got from the manual ZN tuning method.
But I still come back to the,
Yep.
I mean, but even this, right, the time scale, when I see time scales that hint that something's undersampled somewhere, I wonder if the problem is not necessarily in the algorithm, but perhaps in just sample rate mismatch.
Yeah. Just for reference, the time scale you're looking at here, you can see it along the bottom. I'm running a 20 times per second loop. So you're seeing about 5 seconds between the major marks on the time axis at the bottom. So give this thing a step impulse up to 100 RPM, wait about 7 or 8 seconds, and then turn it off.
So you've got about 100 samples per division on that one.
Okay, yep.
Right,
20
5
samples per second.
5 seconds by 20 per?
Right. So I take this exact same code, and the only thing I changed down here was I plugged in the new PID parameters. That's all.
Okay, but wait a second. If this is still 5 seconds, then
There's the timeline.
What?
There's the timeline on the bottom. Same timeline.
So it's 5 seconds per division.
Per major division, yeah.
Per major
20
division.
samples
Well,
per second.
just look at the blue lines, right? That tells me instead of having one step function that lasts for a whole 5 seconds, you've got probably 10 or 15 step functions in there.
Sorry, let me clarify. The blue line is the output of the PID loop. My apologies. I said it was the target.
Oh, not the input.
The output of the PID loop that goes to the bridge, to the full wave bridge.
So it's oscillating like crazy.
Yeah. Sorry, I misstated what that blue line meant. Yeah. Yes. Incredible oscillations.
Well, it's like every sample or every other sample.
Yeah. But the point is, those are the 3 parameters that auto tuner came up with.
Huh.
So what's the red line? What's the red graph?
The red graph is the speed of the motor. That's supposed to go up to 100 RPM and stay there.
Okay, so at a guess, what's happening is that it's still a sampling problem. It's like the auto tuner is probably, it just seems like it. It seems like the auto tuner is trying step functions way too fast together, and then it's interpreting aliased results to generate the tuning parameters.
That's what the auto tuner did.
Yeah.
Yep. Yeah. It basically sends out a reference, right? Because remember, the speed regulator loop's not running now. Only the auto tuner is running. It's not a regulator. It's just a measurement, a stimulation and measurement device. So it gives the full wave bridge a reference, and then it watches the speed to see what happens.
Yeah, but okay, right. So
it doesn't watch it very well. It may be because I'm not in this process here, and it may be assuming I am. I wondered whether I wanted to screw around trying to fix whatever this auto tuner does incorrectly. But to be honest, I'm still farther ahead with my manual tuning method.
Well, so is the auto tuner running at the same sample period as the PID loop?
Yes, it is.
So that might be the problem right there.
Maybe, yes. Not knowing, not having spent enough time to examine the code to understand how it works. I ran it, decided to see what would happen, and this is what happened.
I don't know if I can put this in poles and zeros, but just as a mental exercise, if the control thing and the control and measurement thing is running at the same sample rate as the thing it's trying to control and measure.
Maybe.
Yeah. I mean,
remember, I also have a really crappy encoder on these, well, like wheel encoders on these.
Well, noise, but the loops.
That's the noise.
Yes.
When you look here, see that noise on top of there? That's probably the coarseness of the wheel encoder and the logic that's used to convert it to velocity measurements.
Okay, but that's fine. But think about this, right? So that's just it's like a fundamental Nyquist violation, because you generally want the sampling rate of the controller measurer to be at least twice what the plant is, right?
Okay.
I mean, you want the controller to be able to control and measure much faster than the thing it's trying to control and measure can respond.
Okay.
I mean, otherwise, just think about you have this wet noodle on the gas pedal of a Lamborghini or something, right? So
your suggestion is when I run the auto tuner, I should run a much faster controller and then see what happens.
Run the auto tuner at a much higher sampling rate than the other thing. Just put them in separate loops, right? Decouple the timing.
Yeah.
Run the auto tuner at a much higher rate.
They're two completely different programs, so I can do whatever I want. Right?
Well, there you go. I'm really curious.
That's a good idea, Carl. I never thought.
Got me going. Thank you. But
all right.
I would highly, before throwing mud at I would test it that way.
All right.
And hell, if you can control it 3 or 4 or 5 times faster, let's see what it does.
Anyway, for what it's worth, I was little unhappy.
No doubt, yeah.
So bouncing it off you guys is useful. I may actually try and run it at a faster sample speed.
Oh, this is cool.
And I think that's all I've got here. I did mess around with trying to improve the wheel encoders on my TT motors, but without particularly great success. I took the mechanical wheels. Remember when mice had balls in them that rolled around? and those balls drove those lovely little encoder wheels inside?
And they collected lint.
Well, I pulled one of those apart and got a really nice set of wheels that fit nicely on the ends of the TT gear motors. And I pulled out the optics, the optical sensors used, which are really nice integrated units, hooked up an amplifier, got the whole thing running, and then realized that the TT motor gearbox is so sloppy that it can't keep the little tiny width of the slots lined up with the sensor. But I took it all apart and put it back the way it was. It was a fun experiment. If the gear motors had been not so sloppy, then it would have worked out really well. But it quadrature encoders and a whole lot more slots. Anyway, so I have found devices that. Let me drop this. Stop presenting. I'll present something else. Maybe. And window. And
the only auto tuner I've ever used comes with the GUI for the RoboClaw, and it's just an auto tune button, and you let it do its thing, and it comes out with some coefficients. So It does pretty good though. I have no idea which method it's using to do it though.
But it's probably got a tuned auto tuner.
A tuned auto tuner?
So it's tuned properly. Tuners.
So onwards and upwards, it's always good to have another robot in the works. In my collection of Roombas, this is a clone of a second generation Roomba, which I have pretty much completed gutting. My goal was to keep the frame, keep the motors and gearboxes and the speed sensors, and maybe I will keep the H-bridges. We'll see. It doesn't look very complicated. Plus, there's appears to be some fancy circuitry to condition the sensor, the wheel sensor outputs. So I may hang on to that stuff and hacksaw it off of these boards, and we'll see what happens. But that may well turn out to be my next robot. The interesting drawback is the sensors in these wheel assemblies have extremely high pulse rates. There are 600 or 700 pulses per wheel revolution, but they're only single phase. And I did some research on the entire generation history of Roombas, and they never used anything except single phase encoders in the wheels. I was very surprised at that.
Huh.
Oh, those are the little discs I took out of the mouse. So
Ray, you're muted.
let me close this. So I was quite surprised that there's still only a single phase encoder inside those wheels. So we'll see where I can take that. That's it.
Cool.
Well, if you're always going one direction, there's no advantage in having two phase.
But don't Roombas back up.
Yeah, but they stop first.
And that makes sense, yes. And that's the way the logic works with a single phase encoder to get true velocities. You have to validate that you've got logic that knows the motor stopped, and now you can go the other way. That's what I've got in the logic I've built into my existing robot, which is only single phase.
And I found even if you're just going one direction, you can get on an edge and it'll flip back and forth and it'll think it's moving when it's not.
Oh. Thanks. No hysteresis, huh?
Yeah. Yeah, you need some hysteresis.
You need enough bits to throw some away.
Yep.
The same way that really high resolution analog to digital encoders work.
It's just spatial sampling instead of time sampling, right? Get past the Nyquist and you're good.
Okay, I can put this away. All right. So that was it. I just thought that might be interesting. My auto tuner experience, and Carl's suggestion is good. I'll try that.
I can't wait to hear.
I can show a little bit of progress if anyone's interested.
Yeah.
So I've been working, trying to get my motor driver working. And let's see, entire screen, share. So can everybody see my screen?
Yep.
So I want to shout out again to Chris for helping put that presentation on with the debugger. I've got an Arduino Zero clone connected with that. Incidentally, this is at home and I'm in Louisiana, but I just connected to my home machine and the show.
Sweet.
So one thing I found is when I'm debugging and I'm stopped, I'm not getting any pulse outputs. So when I run it, I don't get anything. And I can get the values back. And you can see in the background I've got some pulses. If I stop it, I get values out of my program where I was and where I'm stopped. And basically, if I let it run, I don't know if you guys can see that well enough. I can't get it to stop scrolling. Maybe if I zoom out a little more, it might come closer to stop. But what you can see is the top trace on my D0 is my servo command for my claw. And the D1 and the D2 trace, and the pulse is getting wider and wider, and it's about 50% or 60% now. It's picking up speed very slowly to say, hey, I'm getting a feedback of 0, so let me put out more power to my motors. So my PID loop is working. My outputs are working. Everything is. So this is the same code I was running on the Renesas processor. And minus the changes I've had to make for the Arduino Zero timing. It gets quite different. Whereas the Renesas is quite simple, supposedly, to make a time pulse. This guy here, to change the pulse width modulation, I've had to grab this guy. So I created this routine, which I just copied to get to a 50 hertz signal. And I put out the signal on, interesting, with the 0 clone, it's pin 2, which turns out to be pin D4. And I don't know why it's different. Something with the 0 clone and the Arduino Zero compared. I haven't tried this code on a real Arduino Zero, so I'd be curious to see what happens. And then I run it on 6. And that gives me a pulse output of pin 4, 5, and 6 total. And basically, I initialize the values using a map function, and I write it to the timer compare 0 bit. Bit 1, bit 2, and bit 3, compare output bits, and with the values. And then I just call my routines to move the clamp to a position, and when I move the motors, it sends a position to the compare bits. So I was able to get it going. If I restart it, it'll start timing again in the background.
So Pat, you have a physical thing running 1,000 miles away right now?
I have a physical thing running 1,000 miles away.
Gold star!
I'm using Rust Desk. I'm using an application, Rust Desk, and it's running on a server. I built the cloud server, and it's supposedly secure to connect me. It's like TeamViewer.
Yeah, but you had to set up your own server, so hats off to you. I was looking at that, and I wound up going with Google Remote Desktop instead.
Oh, I went with Rust Desk. I have a server. It cost me about, I don't know, $6 or $7 a month. But I'm getting supposedly a secure connection back to home. Yep. And so, as you can see, my PID loop works. My SKU just keeps, PID and the SKU keeps picking up the speed as it goes along. And eventually my D1 and D2 channels go to 100%. So that's it. So it's this thing, like you say, it's running at home. I'm just programming it from here.
You're a brave man, Pat.
Well, the robot is sitting up on a stand, and I don't think there's any issue.
You're trusting a lot, and you have no way to recover if anything goes wrong.
Oh, I'm sure my wife will let out a scream.
With my luck, it would catch fire.
So it's not plugged into a battery. It's plugged into a power adapter. I got a 20 volt, or not 20, a 12 volt power adapter, and it'll just unplug itself and fall to the floor and break into a million pieces.
Okay.
was gonna say, you don't have a curious cat, do you? You know, it's like,
No, I have a dog, but she'll ignore it. She's been pretty good at ignoring the robots. So
Do you have a webcam so you can sit and watch your motor spin, or do you just have to measure?
Unfortunately, the computer I'm using is the one that's usually set up on that desk where the robot is. So otherwise, I would have been able to tune in and watch it.
I think that's worth a gold star if we could see that. So,
Running a motor remotely from 1,000 miles away for sure.
Well, it's going to be worth a black star anyway. It's progress. So
that has to be some sort of record in this group. 1,000 miles.
I think to debug a bid loop. Come on, guys, give the guy 2 gold stars.
Well, hang on. I do have a problem with 1,000 miles though. Let's put things right. And technically, I'm Canadian, so it's 1,600 kilometers.
So, hey, Pat, now does this mean that you just gave up on the minima and just threw it away, basically?
No, I haven't given up on it, but I think there's an issue with the configuration for troubleshooting with the CM-SysDAP board. So it's just not configured properly. I tried to write my own config from a couple others, and it's not there. I believe there's 3 files that are involved. And one of them is an SVD file. And I believe that's the one that tells it where all the registers are in the Renaissance board. And I wasn't willing to try to muddle my way through and do all that. I've got a robot to finish building, and I've lost way too much time just trying to get some pulse width modulations out.
Well,
so the whole point of this is to be able to port most of my code out of Python and into Arduino, and then use just my Raspberry Pi will be used just to communicate with my sensors.
Okay.
With some of my higher level sensors, and just report a value back to the Arduino.
Well, I want to know: do Canadians talk smack between each other before the competition? I think Tom should be saying, "Mine runs on the floor," and I'm just curious.
You're muted, Tom.
Mine doesn't run at all. Yeah.
Oh God. Okay. Well, I guess it's not smack time yet.
Yeah. So when I get home, it's time to start tuning PID loops and get into the same thing Tom is working on, and start running around on the floor and go from there.
Cool.
It's use some of the routines I've already got written and convert some from Python to Arduino and put in an arbitrator in there as well.
Okay, that'll be real neat. I'm looking forward to that, to the Canadian remote competition.
I got my wife involved in the competition as well.
Oh,
so she's going to be. I built the arena last year.
Yeah.
And it needs to be painted.
Whoa.
So I've enlisted her to prime and paint it.
Cool. That's fantastic.
That'll be worth some kind of star too, you know. So.
Yeah.
Well, I think I'll plaster her to get her to write her name on the side of the board.
Yeah.
Official sponsor of the 6-can competition.
Yeah. Neat.
So I'm looking forward to it. I was getting disappointed that I'm not making progress, and I'm glad to see that, you know, I've been able to get to here now. I've got some troubleshooting tools under my belt, which helped. I was very disappointed to find out that my PID loop worked, and that it's basically the Arduino Minima that was the issue. And so when I took the Arduino Minima out of the picture, my PID loop went back to working.
Okay. Well, that's cool.
Doesn't always pay to be bleeding edge, I guess. You know, it's better if you...
Yeah, well, that's usually they've been really good to come out with when they announce something that they've got a lot of coverage. They had a lot of contributors that were porting over their libraries and everything ahead of time before the release, so that when they released it, it was there. And it's just not. It seems like it's just not ready to go completely.
Yeah. Yep.
So I do have a problem with the Arduino Zero. Is that I will be, so right now I don't have my encoders tied in because the Zero is 3.3 volts and my encoders on the motor will not run at 3.3 volts. They need 5 volts. So they need 3.5 volts minimum. And that's on the Pololu motor, or the TT motors need 3.5 volts minimum. So I'll put a level converter on the encoders and see if that works.
Oh, that'll work.
So if it works for a digital communication signal, I'm assuming it'll work with an encoder signal and just convert it down to 3.3 volts.
Yeah.
So
I had to do that. Yeah.
Okay. Just before leaving home, I received an Amazon package, some JST, I don't know if it was PH or what connectors, but 4-pin. And it's the first time I ever bought a JST connector with wire tail that actually fit what I was plugging into. I usually have to go through 2 or 3 different versions to get the correct one.
Yeah.
And I'm happy to say it works, fits perfect. So I'll just use that little tail and solder up a little board and just drop it in between my existing wiring and the motor.
Sounds good.
I'm getting tired of rooting through my wire junk box for connectors. So I splurged and bought a couple of these when AliExpress had them on sale. All kinds of JST connectors of different pin numbers, both male and female.
Are those ones you have to crimp?
Yeah. I'm okay with
I haven't got the guts to try to crimp a JST connector yet.
Oh,
I've been buying them pre-made with the tails.
Yeah. I agree, and I bought some pre-made as well for my battery packs. So,
I've had reasonable luck with 2 microns. Okay.
Yeah,
which
those
but if you-
JST come in different sizes.
yeah, well, like I say, 2 micron, 2 millimeter. Haven't had too much problem with 2 millimeter, but the one smaller than that, I don't do them I can't do them at home. Not reliably, at least. So I buy the pigtails, or I buy the one. There's one type of kit you can get on some of them where they have like a stack of wires that have got, I think, a male on one end and a female on the other, and you can select the colors that you want and you just poke them in, and that's a nice kit. Is that what you had, Tom? Or
no,
do you?
this is a very, very basic kit.
Okay, so you're gonna have to crimp. Yeah. Well, usually on the males you solder on, I think, on those. Yeah. Yeah. I'm still looking for a good solution. I think the best solution you can do is one of these guys that makes their own board so that the actual amount of wire is very small. You know what I'm saying? Otherwise you just custom make a PCB. I think that's probably the best solution.
So this came on the AliExpress Valentine's Day sale, if you saw that one. I bought 4 or 5 different things. They packaged them all together and they came in 8 days. That sets a new record for AliExpress.
Yeah.
Are they shipping by hydrofoil now?
I don't know.
Some of the things I ordered ended up floating in the Pacific somewhere because they never arrived.
Yeah. Yeah, Pat, I see those YouTube videos of the container chips in a storm and the container just flipping off left and right, and I'm saying, that's mine.
That's where my parts go, into the ocean. And what's bad with AliExpress is you got to wait. It's like 65 days before you can claim, you haven't got your part.
Yep.
Oh no, I claimed something a lot faster than that. Just recently.
They want you to wait till the shipping window closes before they'll accept a claim, and it's a long.
But in the one I did, they had sent me a notice that it had been delivered, and I never got it. And that might be
Yeah, so
that might be a
if you got a delivery notice and you didn't get it, then that's you can make a claim.
Yeah.
But it's when it's been, it's 45 days and you still haven't got your part and there's a tracking number and it shows it hasn't left China yet.
Yeah.
It's never reached your country of destination.
Yeah.
You have to wait till that window is closed, and it's quite a while.
Yeah.
But you don't have to wait to reorder it because it's not coming.
Well, just pick a different vendor and reorder it.
Yeah.
Yeah, but
AliExpress is pretty good. I've had vendors refuse my claim, and when I appeal, AliExpress just overrides them and says, "Okay, here's your money."
Yeah. I've had that too, Tom.
yeah,
Yeah, I didn't use. Go
battery
ahead.
connectors, but they're reversed. The red is where the black should be, and what could possibly happen?
I looked through 3 or 4 different. I bought them on Amazon, and I looked through 3 or 4 different ones to find a pinout that matched my connector that I needed.
Yep.
And so the black and red are in the right spots, but it's a white and a yellow instead of a blue and a green. But I don't care.
Yeah.
So as long as the black and the red are the right ones.
I looked around and I just said, okay, I'll see if I can switch them when I get them. So, or maybe I'll just stick some, red and black heat shrink on it to remind me that, not to reverse the battery connector. So, but,
Yeah.
All right. Well, feels like the pace is slowing down. Anyone got anything else that they want to share? Or
There's one thing. There's one thing that SRS also sent out a notice saying that they were having their competition. I think it's called Robotron, and it's going to be. Give me a second here. They asked us to talk about it a little bit. Hondo. Oh, here it is. It's going to be on June 8th. So I talked to them and I said, well, I doubt very few of us would be able to make it up to Seattle, but that I thought that we would be very interested in seeing competition run videos. And he replied that, well, we might even be able to have a virtual camera set up. So that would be cool. So anyway, I've always wanted to see, they do one competition where they have like two low wall rooms where they put a refrigerator in one, and I think they put a coffee table and a couch and in the other. And the robot is supposed to go from wherever the starting position is into the room, which represents the kitchen, open up one of these small refrigerators and get a beer out of the soft can out of it, and bring it back and put it on the coffee table. That's the maximum point scenario. Okay. And anyway, I've always wanted to see how they did on that, competitor, because it sounds like a very complex competition, and they've changed some of the rules about how the door, the door on those things is like a big magnet, so it's pretty. It's a pretty good pull to open up one of those guys for a small robot on the floor, and apparently they have made a few rule changes to make that a little easier. But anyway, I thought it'd be interesting. So June 8th, and you can go to their website and see what it is.
So it's a useful robot. That's good.
Yeah.
Cool. And I guess just springboarding off of that, in competition news, there's Robo Games is on in Silicon Valley, April the 19th through the 21st, and so they have like fighting robots, and they are apparently going to run a Robo Magellan run, and not sure what else, but
Yeah.
I think that'd be fun.
Yeah, they usually run a whole slew of competitions. Because it was 3 days, I guess.
Yeah.
I mean, everything you can think of.
So I'm going to try and get there. I don't know if I'll be able to, but that sure would be fun.
Yeah.
That sounds like Robo Magellan to the death. Battle bots.
Yeah, BattleBots are big. All right. Any other last thoughts? If not, we'll call it a night.
All right. Well,
All right. Good seeing you guys. See you next week.
all
It's
right,
good.
bye.
Take care. Night.
Bye, everyone.